Hello, it's Dr. Ron England here again, and I'm going to cover rate of return analysis because, and this is Engineering Economics EGN3613 on Module 10, Lecture 1. So, because we didn't have enough ways to evaluate different types of alternatives for projects, we need to add another one, rate of return analysis, or IRR. And we're going to cover different scenarios involved with this. So I know you're all thinking, oh my gosh, another methodology? Well, in reality, there really is only one methodology. It's just different ways of looking at the same thing. So what do I mean by that? What I mean is like, okay, we've looked at different ways of looking at alternatives and looking at projects and investments. First thing we looked at was present worth analysis, which was pretty straightforward. We just converted all the cash flows to present worth, and then we just compared them to see which one was the best or whether it was actually a good positive thing. But then we said, you know what? That's not how most people think about it. Let's come up with another method, annualized equivalent worth. Well, it's really the same thing as method one, just A over P. Just take that present worth and put it into annualized payments over the life of the project. Still represented as cash, as an amount, as a dollar figure. Well, you know what? There's a third method, rate of return. Okay. Well, really? We need another one? Well, yeah, we do. And there's a reason for that. First, let's talk about what this actually is. It's a relative percentage method, which measures the yield as a percentage of investment over the life of a project. And that sounds like, okay, I'm going to wrap my head around this definition. Relative percentage method with the yield of a percentage of investment. What does that actually mean when you're talking about it in real human terms? Well, if I say this investment will yield a 10% return on investment, that's rate of return. And that's something you can actually say, oh, I'm going to get 10%. I get that. It's a lot easier than saying I'm going to get $17,000 of present worth, because most people have no idea what present worth is. But most people understand I'm going to get a 10% return on this. That's what it is. Now, what does this actually mean? It's the same thing as the other two. Only this time, we're solving for I, solving for interest rate. So, let's just look at a simple example. You know what? Walmart, all those years ago, okay, 100 shares. It was, I think it was $16.50 a share. And, okay, now, in 2002, 1970, it's 32 years, that original investment was worth $12 million. So, you know what? If you'd been back in 1970, it would make a good deal. Now, what happened during this entire period of time? Well, you had a number of stock splits that occurred. If you don't know what a stock split is, you split the stock. If you had 100 shares, you might now have 200 shares. Now, those 200 shares, say you got a $10 cost a share and you split them. Now you had 100 shares at $10. Now you got 200 shares at $5. But the price of stocks changes. And typically when you do a stock split, the share value goes up relatively rapidly, but you now got twice as many shares. So if you look at just the stock split history of Walmart, you started with 100 shares at the original offering, but it split multiple times, split quite a few times. So by the time you get to March 1999, you've now got 204,800 shares, all of which are at a market price that's higher than the original market price that you had on a share per share basis originally. Isn't that great? So if you just do the calculation straightforward, you started with $16.50 out on day 0, and you had in of $12,283,904 at day 32. But now you're solving for I. Okay. And if you do this, you're going to find that I is about 32%. That's a pretty good investment there. If you had taken that original 1650 and you had invested at 32%, you would have ended up with that same amount in year 32. Okay, so what we're really doing is we're looking at the same thing, but really just a different variable. Present worth analysis, find those present worths. AE analysis, find A, that annualized piece. Okay, rate of return, you're expressing the entire thing as an interest rate, as an I, as a rate of return. It's not actually an interest rate, but it actually in reality is an interest rate. Now, one thing that I have to tell you about when you're talking about this, when you get that beautiful rate of return from Walmart stock at 32%, well, the reality is that you also could have invested it in other things, but your basic savings account or stable, no risk investment over that same period of time, we're going to say I'm not going to agree with that 6% number, but it is a number around that number. And at 6%, you're only going to have 10,648. Well, your investment still went up quite a bit. 1,650 to 10,648, obviously 32%, 30% plus is better than 6%. But anytime you've got money going into one thing versus something else, there's always an opportunity cost of not invest. Well, an opportunity cost. This is what you could always get at the time. Understand that there is a concept of opportunity cost, and holding on to your money and not investing in anything has a high. Your opportunity cost is that you're not making anything off the money. Okay, and if you've got money, you should be making money off the money. Okay, money should make money for you. There are safe, almost zero risk investments. Nothing is zero risk, but almost zero risk investments, and there are riskier investments. Walmart at the time may not have looked like this fantastic thing that's going to earn you 32%, but it did. If you look at some stocks, like many years ago when I first invested in Microsoft, a little bit of money in Microsoft, I thought it had capped out. That wasn't going to get that much better. That was wrong as could be, as Microsoft has continued to grow and split and grow and split over those years. And now you'd say, well, gosh, Microsoft must be capped out. Future will tell. So, in 1970, as long as you earn more than 6% investment, it's a pretty good investment. Okay, minimum active or attractive rate of return. That's the MAR. Okay, our return on investment. Okay, our rate of return on this one, pretty good thing. Now, why do people like this? Why expressing it as an interest rate? Why is this so popular? It's pretty straightforward. I kind of said it. By saying, if I go to you and say, hey, I got an investment that's going to give you a 20% rate of return, you're going to go, wow, that sounds pretty good. I understand interest rates. I understand 20% is a good number. However, if I say, you're going to get a net present worth surplus of $10,000 from this project, you're probably going to go, well, it's positive, but I don't know what that means. So, reality is, especially now, as an engineer who actually understands economics, get it? You are an engineer, you need to understand economics because guess what? It's expected that you do. However, you will understand that project saying, hey, the present worth has a net surplus of $10,000 in net present worth. Now, you're going to immediately ask, but what's the magnitude of the investment? Because a net surplus of $10,000 on a $1 million investment may not be that great. However, if I say 15% rate of return, you say, well, shoot, I'm putting $1 million into that sucker. Okay, so return on investment. There are multiple definitions of the way that you can say this. Rate of return is defined as the interest rate earned on the unpaid balance of an installment loan. We're going to actually look at some of those dot numbers like that. But essentially, it's what you're getting from that money. So, you can calculate this. If you lend $10,000 and receive annual payments of $4,021 over the period of 3 years, I think you can calculate that that's going to be a ROI of 10%. Okay, I expect you to be able to calculate that. Annual payments of $4,021 over 3 years. Okay, you can get that to present worth. It means you can do this. Okay, loan balance calculation. Yes. Do I expect you to be able to put this into a spreadsheet? Most 100% definitely so. How do you do this? Okay, original balance. The original balance has 2 pieces in the next year. The percent, okay, and the principal, the interest in the principal, which then go, and then any additions that you put to that money. And if you're doing this as a loan balance calculation, I've given you this. I've actually given you my mortgage as a spreadsheet. It's the exact same thing right here. When you get down to year 0 or year 3 or the year that's the actual payoff, it should be 0. Now, what is the interest rate that goes with that? You solve for it. Pretty straightforward, 10% interest. Now, we're going to talk about ways to solve this, by the way. You know one. So, another definition. It's the break-even interest rate, which gives you 0 between the present worth of the cash inflows and the cash outflows. Okay, that interest rate is if you took all those cash flows, okay, in and out, and you zero out the present worth at that specific interest rate, that is the rate of return. Another way of calculating it. Just set present worth equals to 0 from the inflows and outflows, and voila, magic occurs. But you got to solve for I. So you got some methods to solve this. Well, one is Excel's got a financial calculation that's involved. IRR. It's got an IRR function built into it. Nice. You do have to give it an initial guess. Okay. Yeah, voila. Not too hard. And they're going to see why an initial guess is kind of important later on. Okay. Or you can just solve for I directly. Sometimes that's a pain to do because I shows up in an exponential inside of the term of an exponential. So you're going to have to do some logarithmic mathematics, or you're going to have to, in many cases, actually in quadratics. The other one is trial and error. Just try it. And there are calculators, cash flow analyzers, many of them available freely online, financial calculators that will let you do this. Okay, you can actually analyze cash flows and give you rates of return. I'm not going to cover those. If you want to Google them and use them, be my guest. Just make sure you know that you're using one that works and that you know how it works. I would validate the calculations of the cash flow analyzer with one that you know, or maybe one that I gave you. So, IRR. Here it is. Some cash flows, 0, 1, 2, 3, 4 years. IRR, you just take the cells, boop, 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 and it calculates your IRR on those cash flows. It's pretty straightforward. That's an easy one. That's really good if your cash flows show up perfectly annual, perfect annual amounts. You just put them in a line, assuming that they're on the period of the interest rate, which would be annual, and you're good to go. Now, got some other. Now we're gonna look at the quadratic, and that's going to show us some issues. That when you're dealing with some of the more complex cash flows, they can get a little bit more complex. Trial and error is just simply put up your spreadsheet that has all the cash flows, calculate the present worth, and play with interest rate, putting in different values until it zeroes out that present worth at zero. And of course, you got to solve for it. They can do exactly the same thing, which you hopefully by now have learned to use. If not, oh my God, get on top of Excel. If you don't know how to use Excel, you're going to be at a serious disadvantage. If you need help on how to use Excel, I will create some videos for you to do it. I need to know what you need help on, because I'm kind of assuming that all of you have at least some capability of using a spreadsheet. By the way, if you don't have Excel, this is all also in Google Drive, in the spreadsheets in Google Drive. Okay, there's no reason not to know how to use a spreadsheet. Okay, do it. Okay, unless you really like plugging stuff into a calculator for hours on end. I don't. I'd rather use Excel. So let's look at some of these. Direct solution. Project A, direct solution. Boop, boop, boop. You got that first one you need to solve for I. Okay, in other words, present worth and future worth, and you solve for I. And notice I've got to take the log, and that first one that's over here. Voila, voila. But I can solve for I. Okay, that was that first one right there. You got the present worth, you got the future, you got two cash flows there. Boom, boom. Okay, this one you look at, you got some cash flows over multiple years, 0, 1, and 2. Okay, present worth set to 0. Notice you got squared there. So now if you put this, you just say x is equal to 1 plus I. That's an easy way to go about that, because now you just have 2,000 x squared. Once you solve for x, you can solve for I. And now you got two interest rates. Now, you're not expecting to be why do you have two interest rates? It's a quadratic. You're going to get two answers. By the way, put 3 years in there, now it's a cubic, and you got 3 answers. Well, that can get interesting. Yes, it can. We're going to talk about it a little bit more later on. So which one do you think this actually is? Well, a negative 160 makes no sense. We're going to go with 25%. Actually, good. And let's see another one. Trial and error. Put those cash flows in there. Change your I. See what you get. Okay. Eventually, you're going to get the answer. Or maybe you can bracket the solution and you can interpolate. Of course, that's a linear interpolation, and that is an approximation, because guess what? It's not. It's linearizable, but it is not linear. In other words, it can be solved through linear methods, but it's not a linear equation. So the rule: rate of return beats the MAR. It's a good project, just like all the other ones. No change. Now, I think you just showed in that last example, with one of the methods, when we were doing the quadratic method, we had multiple rates of return. Ouch. Well, first, which one's right, and how do you actually make the decision to accept the thing? So if we look at this one, now here's the situation. The concept of a simple or non-simple investment. Simple investment is there's only one change in the direction of the cash flow. In other words, the cash flow is negative, 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 positive, positive, positive. There's one directional change in the cash flow. It could be positive, 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 negative, negative, negative. It doesn't matter. That'd still be a simple investment. A non-simple investment, however, has a problem. Got to deal with this. This cash flow is negative, then positive, then negative. They can be negative, negative, positive, 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 negative, positive, negative, negative, positive. You know what that means? There can be multiple solutions to I, to the rate of return. Because, yes, it will actually solve into a quadratic. So, if you're looking at these different projects, you're going to see, if we plot the present worth versus I, which you, by the way, can do. And you know how to find those crossing points of where the present worth is 0. Well, project that's a simple investment, only going to cross that line once. But a non-simple investment can cross that line multiple times, and now you got multiple possible rates of return on the project. You don't even know which one's right. Let's do an example here. Let's actually play with this a little bit. So let's look at this one, multiple rates of return problem. Here's one that actually does. You got negative out 1,000, 2,300 year 1, 1,328 year 2, negative. Okay, there it is. Present worth is equal to that. There it is. It's straightforward. By the way, remember I told you there's only one equation you need to know. 1 plus I to the n. That's it. That's the one you're going to use. Okay, you just need to know to, okay, do you multiply or do you divide? Present worth is divide, future worth is to multiply. It's not that hard. Okay, now all those other equations that you have for gradients and all those other things, that's just solving, just playing it in different ways. It's the same equation over and over again. Now, okay, for this, let's go ahead and solve this. And if we solve for I in this case, we're going to find that it's 10 or 20. It's 10 or 20%. Well, those both, not only this, they both look feasible to me. I was like, which one is it? Is it 10 or is it 20? If I plot it, present worth versus interest rate, you're going to find, look at that. There's a whole chunk of space in there that thing's positive. It's above 0. Okay. What are we doing here? It's got 2 answers. Hey, if you're an optimist, it's 20%. If you're a pessimist, it's 10%. We can go that route. And if you were to take the cat, remember I said you need to be able to do this like a loan. If you're able to do this like a balance on a loan or a balance at a bank account, if you put in 10 and you put in 20 at year 2, they both balance out to 0. You put the numbers in and do this. So you prove that they're actually both 0. How do we deal with this? What are we going to do? There actually is another methodology to do this. Okay. Well, here's the problem. 10 isn't a true rate of return. 20 isn't a true rate of return. So the reality is they're both invalid. Great. Is there a way to do this? Well, as you recall, I gave you, whoops, that's kind of hard to read, isn't it? Let's see if I can slide this baby over so you can see it. There we go. As you recall, there were other methods. Rate of return is not the only method to solve this. Do comparative analysis. Just go back to net present worth method. That always works. Okay? You can always tell if that's a good one. So, is there a way to deal with this? Of course there is, because it's money. People study money ad infinitum. People love money. People have all sorts of ways to deal with money. So, if you got this odd plot that gives you multiple potential rates of return, you've got the ROIC method. Or just go back to the present worth method. That's always going to work. Just go back to PW. Now, if you really want to know how to do ROIC, we're kind of getting into some more advanced type of things here. Return on invested capital, but never hurts to know how to deal with money. Okay. And guess what? One of the most hired groups of people on Wall Street are engineers. Why? Because we do math and we can know how to deal with it. But here's a place that you can look at ROIC, or just Google it. It's not that hard to find some different places if you really want to understand different methods for dealing with this. This is lecture 1. I'm hoping that, now remember, concepts. I'm going to do a quick review of the concepts. You understand time value of money. And there's one equation I expect you to know, memorize. 1 plus I to the n. Just know how to apply it, present worth, future worth, because it can always be used in all cases. Okay, then you've got all sorts of other ones for annualized and everything like that, but it's still the same. They all are just derived from that one equation. And then there's adjustments to that. How do you adjust for inflation? And then a lot of different definitions you can deal with. But that one basic concept always applies. Now, when comparing analysis, you're still using the same equation. It hasn't changed. Present worth analysis, annualized rate of return. Solving for PW, A, or I. 3 different solutions for 3 different things. It's the same thing. So essentially, we've spent the first half of the class learning how to do the same thing a bunch of different ways. And hopefully learning how to read word problems, because a lot of times the wording is a little bit tricky. Anyway, that's it for now. I've got one more lecture for this module, and then we're going to move onward.